Hello everyone, it's that teacher here, and today's lesson is going to be on equivalent fractions. Let's start learning. Welcome back to the channel everyone. Thank you so much for joining us here in today's lesson. Let's get straight into it. So today's lesson on equivalent fractions, we're going to increase the difficulty from our previous lesson on this channel. Now the previous lesson on this channel was more of a beginner's lesson. This lesson ramps up the difficulty slightly so that we can extend our understanding of equivalent fractions. So in our fraction here, we have 2/3 is equivalent to the numerator we don't know, the denominator we have 24. So as our previous lesson said, we need to work with both denominators because we do not have both numerators, so we're missing a piece of the puzzle there. And we do have both of our denominators from either fraction, from both fractions. So we need to think, what has happened to 3 to equal 24? So we have multiplied 3 here by something. So this is where it's super important, it's fundamental, I can't stress the importance of knowing and understanding your times tables. Knowing your times tables will just make everything in maths, especially fractions, so much easier. Fractions rely so heavily on an understanding of multiplication, so you need to practice your times tables as much as you can. So as you can see here, 3 times 8 we know is 24. Now, as always, the golden rule of equivalent fraction is whatever you do to the denominator, you have to do to the numerator. So we know that we have to times 2 by 8, giving us 16. So it's straightforward, it's simple. We're just dealing with larger numbers. So I'm going to run you through 4 more examples so that you can consolidate your understanding of equivalent fractions. In this fraction, we have 1/2 is equivalent to something over 24. So what have we done to the 2? What has 2 been multiplied by to equal 24? We know that is 12. So if you go on your times table chart, you can see that 2 times 12 is 24. Now, as you know, whatever we do to the denominator, we have to do to the numerator. Now I'm going to be saying that a few times this lesson. It might be a little bit irritating, but I really want to stress the importance of knowing the golden rule of equivalent fractions, which is whatever you do to the denominator, you have to do to the numerator, or vice versa. Whatever you do to the numerator, you have to do the same thing to the denominator. So 1 times 12 is 12. So 1/2 is equivalent to 12 over 24. Our next fraction we have is 3/5 is equivalent to something over 40. So what has happened to that 5? What have we multiplied that 5? Remember, we have both denominators, so we're working with the 5 on the left-hand side. What have we multiplied 5 by to equal 40? We know that's 8. Whatever you do to the denominator, do to the numerator. So 3 times 8. So your answer here, your missing numerator is 24. Going through the third example, we have 3/4 is equivalent to something over 36. So how much have we multiplied 4 by to equal 36? We know that that answer is 9. Remember, whatever you do to the denominator, you must do the same thing to the numerator. So 3 times 9, that equals 27. So your missing numerator here is 27. Finally, I've put a larger one here just to show you a little method how to work this out. So 2 over 5 is equivalent to something over 100. Now we need to think, how many 5s, what do you times 5 by to equal 100? Now not everyone will know that it's 20 off the top of your head. It is 20. However, an easy way to do this is to turn this into a division question. So if you divide 100 by 5, you will get the exact same answer because multiplication and division are inverse operations, so they are extremely close and they work together. So 5 times 20, remember, I'm gonna say it again. If you don't understand what that times table is, you're not sure, because who knows 5 times 20 off the top of the head, 7 times 20, 8, you know? So what you need to do here is divide 100 by 5, which gives you 20. So remember, whatever you do to the denominator, you have to do to the numerator. So 20 times 2 equals 40. So hopefully my guided examples have helped you in your understanding of equivalent fractions. On the next slide, I have given you some questions to do at home. Follow the same strategies. Whatever you do to the denominator, you need to do the same thing to the numerator, okay? So follow that. I'm going to flick the answers in a minute. Now, thank you. If you've made it this far, thank you so much for watching. I really appreciate all the support, and hopefully this lesson has helped you in your journey to understand equivalent fractions. All right, I'm going to show you the answers now. Here we go. Here are your answers with the working out. Of course, I'm always going to show you that working out so that you can cross-reference the answers on the screen with your working out at home. So I know that if you followed our simple steps, you would have absolutely nailed this. Thank you so much for watching today's lesson on equivalent fractions. Like and subscribe. We'll see you in the next lesson. It's that teacher.